Hey folks, it's Jennifer Steele and I'm back with part 2 of our data task for Uncommon Sense Analytics. And this is a continuation of the data task where we're simulating data based on how marital couples communicate, trying to simulate data from a 1992 study from John Gottman, who's kind of the relationship guru. And so where we got in the first video is we created husbands and wives variables and their ages. And then we tested our code against code written by ChatGPT and Copilot. And we found that Copilot was able to come pretty close to what we had done. And ChatGPT caused us to run into some difficulties. So I'm going to take us in this exercise through the next part of our task of simulating the John Gottman data. And in this one, in some ways, it's a bit easier because we don't have to worry about not going below the minimum age of 18 for participants in the study when we're creating these fake data. But our task here, we still have some little tricky aspects. And so what we're doing in this task is we're creating a binary variable for whether the couples have regulated communication or not, whether the couples from this John Gottman study from 1992, it's a very old study. And they divided couples into those that were regulated, like emotionally regulated in their communication styles, and those that were not. And those that were regulated and had healthy communication styles, their marital happiness was 104. And the unregulated couples, it was only 90. Out of, they don't say out of what, but they tell us that the standard deviation for regulated and the standard deviation for people's marital happiness was about 22 points. So this gap of about 14 points is nearly 2/3 of the standard deviation, which is a big gap. That's why this is a cool study, because it shows how important it is how people communicate in marriages. It really makes a difference in terms of distinguishing between unhappy, more and less happy couples. This is a big gap. So what we're going to do in this part of the task is we're going to create a binary variable for whether the couples were regulated communicators. And regulation should be coded 1 for randomly chosen 42 couples, and it should be coded 0 for the other 31 couples. And a random variable called marital satisfaction should be created for each person with a standard deviation, which we got from the study, of 22.43. And here's the tricky part, because it doesn't tell us what is the mean for each group. It tells us that, these are some notes that I made in my own do file. It tells us that for males, marital satisfaction was 96.8 with a standard deviation of 22.16. For females, it was 98.56. It was about 1.8 higher, and with a standard deviation of 22.7. So we're going to use an average or pooled standard deviation for the whole group. And we're going to assume that that gap of 1.8 between husbands and wives is evenly divided, is the same for whether they're regulated or unregulated. So we're going to take what the study says, their unregulated marital satisfaction, which is about 90. If they're in a regulated communicators, it's about 104. And we're going to assume that the gap for males and females is roughly the same as the gap that it is overall. So that means we're going to take that 1.76 gap between males and females. We're going to bump up the overall average by half of that, 0.88 for, we're going to bump that up by 0.88 for females and take it down by 0.88 for males, which will give us that nice gap of 1.76 between males and females in highly regulated communication styles. Same thing for females and males with unregulated communication styles. We'll just bump up the overall average by 0.88 for females, bump it down by 0.88 for males. These lines are just me doing that math and having a record of that math of how I got to these numbers. Okay, because when you use display and you type in the math, Stata just shows you the math like a calculator. So it just does the math for you and it tells you the answers. Okay, so we want to, I'm going to take us through the steps that I'm just going to rerun the steps that we ran in the last video of creating the data set. And then we're going to start focusing on the part where we create the marital regulation variable. Okay. So I've brought us up to speed with the data set that I created last time. Oops, let's clear. And now let's run that again. Okay. So now I've got my own data set that just like I showed you that with my own code from the last video. Now we're going to create a positive trend variable that is basically the regulated versus unregulated variable. And it's going to be, we're going to create a uniform distribution, which has in Stata or a uniform distribution is just a flat random distribution. And so this is going to have a range from 0 to 1. And we're going to say, because we know that about 42% or 42 out of 73 people in the study had regulated communication styles. It was 42 out of 73. We're going to choose randomly which couples are going to be categorized as regulated. And we're going to call those positive trend equals 1. So if they get a random number that is in the bottom 60% of the distribution, because this is really about 57%, but I just want to make sure we really get 42 people with a yes. So we're going to create this random variable, and then we're going to apply it. We're going to drop it if it doesn't apply to wives. And then we're going to generate it so that it's the same variable for both the husband and the wife in the couple. So we're going to create this pos trend uniform. Is going to be 1 if uniform random number is less than 0.6. Greater than 0.6, it will be, pos trend will be 0, meaning they're not a regulated couple. And then we're going to drop that if they are a husband, because we want to make sure that the husband and the wife have the same value for the whole couple. So that means that we're going to sort by couple. So here's our couple variable. This is couple 1, couple 2, couple 3, and we're going to sort by couple and make sure that we take the average of whatever is pos trend for the wife. We're going to just take the average for each couple, and that will give the same wife score to both the husband and the wife. So when we run the first line, we get this new variable called pos trend, which is positive communication trend. And that should be positive for about 42 out of, so tab pos trend. Let's see. Oh, it's not exactly what we wanted, because what we want is 84 and 62. So that's what happened. This is the downside of random number generation. We could just choose 42 on our own, but let me try this again. So, except it'll probably, since we set the seed, it will probably give me the same value. Oh, no, it didn't. Okay. So that means that, now let's see what we got this time. Tab, pos trend. Oh, no, no better. Huh. Okay, here's what we're going to do. We are not going to do this randomly. We are going to say that generate reg equals 1 if it's, so 42 and 42, if n is less than or equal to 84, and replace reg equals 0 if n is greater than 84. And so that should give us exactly the amount of couples regulation that we need. So let's see if that works. Oh, J reg equals 1. Replace reg equals 0 if n, left out my n. Okay, now let's tabulate reg. And see what we get. Yep, now we have, so we didn't choose them at random, but these are all fake couples and they don't have names attached. So we just chose, everything else has been done at random. So we just chose the first 84 to be regulated and the last 62 rows to not be, which means that we wind up with 42 couples with regulated communication and 31 otherwise. Okay, so that is how we did that. So that means these other steps we ended up not using because those random generators were not giving us the precision that we needed. Okay. So now we're going to generate satisfaction, marital satisfaction, and we're going to do normal distributions. So let me set the seed again for good measure. And so the normal distribution, we're going to do normal distributions with the means for each subgroup. Wives are 104.96, and with a standard deviation of 22.43 if they're regulated. Otherwise, it's 90 and 22.43 if they're with standard deviation of 22.43 if they're not. So we end up with 4 different groups, and we're going to create those 4 different random distributions. And now we can just look at the satisfaction statistics for couples that are happily regulated communicators. In our random numbers, wives have a happiness rating of 110 and husbands of 104, which is a little higher than in the real data. And wives have a happiness rating of 89 and husbands of 88 if they are not regulated communicators. So that I think is a little bit lower than in the real data, but still relatively comparable. And that's because we're generating random data. So now we're going to visualize that, because in the real study, in the original study, which is here, you see that they only show this in a table, and it's kind of buried in a tiny table, table 3, where you see at time 1, this mean difference between regulated and unregulated couples. But I think it's more interesting if we can visualize that and show it separately for males versus females and see what does that really look like. And so we're going to do this with a box plot. And so if we do the box plot right now, I'm first going to do it in a very simple way, which is graph HBox, and we're going to do it over wife and over reg. And it's going to be very simple and basic, because this shows marital satisfaction on the horizontal axis, and it shows the middle of the box is the median. But it's hard to tell here on the left, what is a husband, what is a wife, what is a wife, what is a husband, what is regulated, what is not regulated, nothing is labeled. And so it is hard to tell. I can kind of infer that the bottom is couples that are highly regulated because their satisfaction is higher, and couples at the top are not regulated because their satisfaction is much lower. And you can really see those gaps in those medians. And what you see out here with the box is the interquartile range between the 25th and the 75th percentile. And then you have the 95th or the 5th and the 95th percentile with the whiskers. And then you have kind of the outside values. So it's not very well labeled. So we're going to improve on that. And the way that we're going to do that is we're going to create value labels for, we're going to call it wife underscore F for, why do we call it F? Format. Wife underscore F for format, reg underscore F for format for regulation. And we're going to say that if it's a 1, it's wife, it's 1 regulated, 0 is a husband's, 0 is not regulated. And because I'm doing this for the first time, the option is add instead of modify. And so we're going to run those 2 lines to create those labels. And then we're going to attach those labels to the variables. We do that with label values. So we're attaching the values wife F and reg F to the variables that go with them. So it's label defined to create the labels, label values to attach the labels to the variables. So that's in lines 92 and 93. We do that. And now when we look at the data, we see those labels attached. Now they're in blue and their wives and husbands in blue instead of 0s and 1s and 0s. Now we're going to create a label for the variable marital satisfaction. Instead of just calling it satis, we're going to give it a label for the whole variable. We're going to call it marital satisfaction. That's line 94. We run that line and we see that that works because now we see the label here on the left in our variable sorter. Finally, we're going to make the graph again. This time, we're also going to add a title, which is satisfaction by communication regulation. We're going to add a subtitle with the sample size, 73 married couples. And we're going to add a note that these are simulated data from Gottman and Levinson. So when we run that line, now it looks, I don't know if it looks vastly better, but it looks somewhat better because we now see a bigger gap. I mean, it's clear that there's a big gap between not regulated and regulated in terms of the medians in the middle of the boxes. And it is clear that that husbands and wives are pretty similar. Their medians are about the same within the same category, but that couples that don't know how to communicate well, their marital satisfaction is quite a bit lower. And so we can also see this in the summary data, summarize, and we want to summarize. That is by red, by sort, red, some status. Let me make that a little prettier. And we run that command again. And so, yeah, you can see that there's now this, in our simulated data, there's an even bigger gap than in the real data. This is a gap of almost, this is about 19 points between, well, this is 89, so it's about 18 points between regulated communicators and non-regulated communicators. And with a pooled standard deviation that did come out to be just under the real data, it's 22. Here it's about 21 averaged across. That means that we're almost a full standard deviation apart in our simulated data in terms of marital satisfaction. Of course, the maximum is much higher, and the minimum is also quite a bit higher for couples that are good communicators. So that's getting close to a standard deviation, which in the real data was really more like 0.63 standard deviations, or yeah, it's about 0.63. So still a big difference, which tells us that that's why this is a powerful study that has lasted a long time and still gets cited, because it shows this gap in satisfaction between strong and weak communicators. Okay. So we're going to do the thing again where we give the task to AI and see what it can do. This time we're going to give the task to Claude. And we're going to ask it to make the box plot graph as well as creating the binary variable. Okay, so we gave it to Copilot. It did a good job. We gave it to ChatGPT. It did a decent but not great job. And so now we're going to give it to Claude. Okay, we're going to paste this in. and see what happens. So of course, it's a different task than what we gave in the previous video. So let's create the data set. Oh, interesting. It's thinking. It's taking a little bit longer. Oh, you know what? It's not using Stata because I didn't tell it the first part. That's why. Okay, we need to stop it. I cut and pasted without building on what I had done before. Okay, so. Okay, I'm going to take out the part about the age variable because I don't want to confuse it. I'm just going to have it do the husband, wife, and the regulation. Okay. So we need to go back to Claude and see how it does. Claude. Oh. Now, let's try a whole thing because of course, it didn't. I had not given it to Claude before, so it didn't remember. Oh, and you can't see what I'm doing. So we are going to screen share. Okay, when I give the task to Claude, it will set the seed, clear the data, set the observations, generate the couple variable correctly, generate the wife variable, what appears to be correctly. Keep couple, duplicates drop, generate random. Oh, okay, that could work. Okay. It's a little complicated how it's getting the random. 42 couples that are regulated versus not. It created it kind of in a separate data set and merged it back in. And let's see. So it looks plausible. Let's copy it. Let's put it into Stata. Let's put it into our do file. And let's put it into our ChatGPT do file where we have ChatGPT, then we have Copilot, and now we have Claude. Okay, let's run it and see what happens. So it will clear the data set because that is its command on line 78. So I just ran the first few lines. Now it will set the observations, generate the couple variable, generate the wife variable. So let's see how it does on that. Let's observe, and it looks good. The couples look correct. 1, 1, 2, 2. Wife is a 0, or this is husband, wife, husband, wife. So it does it the reverse of how I did it, but still works. Okay. Now let's see how it does with deciding which 42 couples get to be regulated versus unregulated. So let's run those lines and see what happens. So it's going to kind of step out of our current data, create a uniform variable. If n is less than 42, and then save that temporary file and merge it back in. So we're going to then merge that back in and rename reg temp, the temporary variable, as reg. And let's see what happens. Invalid file specification. Reserve. Oh, okay, let's see. Okay, let's do a tab and see how it worked. So tabulate or just tab. Reg. Yeah, it worked. So 84 regulated couples and regulated individuals in regulated couples, and 62 who are not, which is 31 couples. That worked. So then it generates the satisfaction variables. That looks pretty straightforward. Its code looks identical to mine. Wow, its code looks really identical to mine. And then it's going to create the value labels and assign them. Then it's going to create the box plots. Wow. The only problem is that its title is running off the line. Its title is too long. Marital satisfaction by gender and communication regulation. If I just say marital satisfaction by communication regulation, it might fit. Let's try. No, it still runs off. Let's just get rid of the word marital. Okay. Yeah, that works. And so now their data look different because even though they started with the same seed, their data generating process assigned different couples to be regulated and not regulated as compared to our process. And so their gaps look a little bit different. Wait, is that why? No, it shouldn't be why. So let's see what their main differences are. Summary is I sort red sum status. Okay. So their means look pretty close to the original data. For regulated couples, 104. For non-regulated, 87, which is a little lower than the real data. Standard deviation slightly lower than the real data, but the distributions look plausible. And it looks a little bit different on their graphs, but you can still see clearly these means that are higher by about 17 points, same as the real data. But their standard deviations here are a little bit smaller, so that's going to be display 17 by 21. So they're getting a standardized mean difference of effect size of about 0.8 standard deviations, which is again a little bit larger than the real data. So this is what we produced by following the code of Claude. So Claude did a great job. Copilot did a great job. ChatGPT got a little tripped up and we would have to do more troubleshooting there. But every time the code does something that we didn't anticipate, that is also a chance to learn and to learn a new syntax, a different way of doing something that we already knew how to do, because there are many, many ways to do most of these things that we do with code. So I will stop there and just recap that what we've learned to do is generate fake data to simulate using random numbers to simulate data that we've seen in published studies, to visualize it, illustrate it, play around with it, and estimate or simulate what might happen under different circumstances or if analyzed in a different way. Of course, we don't have the real data, but knowing how to simulate data is a great way to test different techniques or to test the sensitivity of our results to different kinds of assumptions. So that is what we learned today in Uncommon Sense Analytics. And this is part 2 of the 2-part task. And I'll see you guys next time. Thanks for watching.